What's going on, everybody? It's Mr. Gustin. I'm back in the physics classroom today. We are talking about our car push lab. It's the lab where you were asked to go ahead and push a car, a truck, a minivan, whatever it was, and figure out what the mass of the car was. So in order to do this, we started with two FBDs. We knew, let's go FBD first. Okay, ready? Here we go. I got a car. On that car, I'm going to push. I had like three people pushing. Let's call it FA, FB, and FC. And ABC are our classmates. We were all pushing on the car together. When I pushed on that car, there was also a resistive force I had to push against. And that resistive force was the force of friction. This marker is no good. Get rid of it. That went in. Anyway, we have this. So now what we do, we go ahead and we write an FBD we write an F net for our FBD. We say F net in the x direction. It's always equal to MA. It's the A of the system, how fast the whole car or truck is moving. And we say, okay, I've got FA plus FB plus FC, because all of us push in the same direction, minus the force of friction. If I add all these up, I call that a net force, a total force. I add those up, and I say that equals the mass of the car or truck times the acceleration, and I'm going to label that. Now, if I go outside to do this lab, I can measure these ABC forces using my push scale. I can measure acceleration probably using some kinematics tools, some distance and time stuff, but I'm still unsure about how to find the force of friction. How can I do that? What can I do to find I don't have like a frictionometer in my pocket. I can scan the floor and find friction, so I have to come up with a tricky method. Here's the method. If I go ahead and push, I'm going to slide this aside. If I push something at a constant velocity or zero acceleration, we can go ahead and say V is constant. If I push something at a constant velocity, well, that means the forces are balanced, because acceleration is zero, net force is zero. So if I push at a constant velocity, my push force is equal to my friction force. So I have my first procedure. The first procedure is going to be push on car at a constant velocity. And if I do that, then the subtext there is that F push will be equal to force of friction. This is the key. I push at a constant velocity to ensure that these two forces are balanced. Whatever I read on my scale for my push force, this comes from the scale, whatever I read on that is my force of friction. So then, when I come back to my original idea, me and my three classmates, when I come back here and I measure A, B, C on the scales, I already know what the friction force is from my previous experiment. So I actually have to push this truck or car twice. I push it once at a constant velocity to find friction. Once that's done, I push at a constant acceleration to find the net force. Once I have this net force, and as long as I've used kinematics to find this acceleration, distance and time, somehow think about that. Once I figure that out, I should be able to find the mass of the car. I'm not going to give you the answer, but I've just given you the procedure. Figure it out. You got questions, send me an email, drop me a comment, whatever. See ya.